All right, we're just continuing from that first video. So now the minor arc is less than 180 degrees. Now let's do an arc. What do you think? We did one that's less than 180 degrees. Let's do one that is, that is greater than 180 degrees. So let's make this go right here, and let's take this to here. Girls, pay attention, please. Look up here. Mufasa, please look up here. All right. All right, so watch this. Let's say, I'll use the same angle. Let's say that's 150 degrees, but it's like this. Now watch. What we're going to do is I don't want to talk about this angle right here. I know from here to here is 150, so if I name this AC, I'm not being very creative on my letters here, but that's okay. So if I said arc AC, you know I'm talking about this one. Well, what if I want to talk about this arc that goes around here? Could I just call it AC? No. Could I just call it CA? No, because you wouldn't know which one you're talking about. I don't know if I'm talking about this one or if I'm talking about this one. Well, the one that's less than 180, we use two letters, don't we? All right, so if I want to talk about this one, what else do I need in here? I need another letter in there, okay? So let's call this D. So now I could talk about this arc. Let me try, oops. What's that? B? I don't know why I didn't use B, to tell you the truth. That was weird, wasn't it? That's okay. We can use D. We're fine with that, aren't we? That doesn't bother you too much, does it? All right, so now look at this. If I want to talk about this arc that I've highlighted in red right here, I'm not going to call it AC, even though it does go from A this way all the way to C, doesn't it? Yeah. Guys, please. Okay, are we ready? Thank you. So if we start at A and go all the way around to C like this, I don't know which one I'm talking about. So I have to have another point in there so I know what I'm talking about. So somebody said it already, but if we had a minor arc, what do you think the next one's going to be? Yeah, absolutely. And if the minor arc was less than 180 degrees, what do you think the major arc is? It's greater. We say greater than, don't we? No, we don't say more than. Greater than 180 degrees. Now, on a major arc, we don't use 2 points. We use what? 3. We use 3 points. So I could call this arc what? This one that's darker, ADC. Very good. So I could call it arc ADC. Now just looking at this and seeing I have 3 points, I know that's going to be a major arc. Okay? You could say CDA as well, couldn't you? All right? But the A and the C, the end points, they have to be on the ends. You can't go DAC. That doesn't, well, DAC would be a different arc. It would be this one, but it's not the one that's highlighted, is it? All right, you with me on that? All right, let's do another one. Let's go, let's do this. Okay, I go right through the center. All right, I go right through the center. What do I have here? I've got a diameter, don't I? And it cuts off an arc as well. Let's call this A, and Isaiah wanted a B in there, so we'll put a B. All right, so, but what if I was going to, just right there. What if I wanted to talk about this arc right here? Could I just call it arc AB? No, because if I was wanting to talk about this arc, again, let me try to highlight it. Oops. It's a little slippery on this graphics tablet. It's a little harder than on paper. Paper, you have a little friction, you know. On this, it's kind of slippery, so it's kind of hard. Anyway, let's continue with this. If I wanted to talk about this highlighted arc right here, I couldn't just say AB. Because who knows? Somebody would have thought I was talking about this one right here. So again, what do you think you need? You need another point. So we'll call that C. All right, so now I could call this arc A what? The highlighted one, CB. All right. Now, this is not a major arc. It's not greater than 180 degrees. What is it? It's equal to 180 degrees, and that's correct. It's a semicircle. And a semicircle is equal to 180 degrees. Now, a semicircle is still an arc. All right, you follow me? We don't think about that very often, but a semicircle is an arc. It's an arc of 180 degrees. All right? There's a couple cool things we'll do a little bit later with a semicircle that I think is kind of cool, and hopefully you'll see that as well. All right, let's see what else we have to do. All right, this thing right here we're going to do is, again, not that difficult. I'm just going to put a few points here. I'm not even going to put any radii. Let's go to another color. We haven't used blue, have we? Let's use blue. So let's say that's blue right here, and right here. And we'll call it Again, for lack of imagination, I'm going to go ABC. All right. So this is just, it's a real simple thing, but just watch. If I took arc AB and then I connected it with arc BC, what do I get all together? If I took AB and BC and connected them together, what would I get? Say it, Courtney. I get arc AC, exactly. So you can actually do addition with arcs. You can do addition with angles, right? You can take angles and add them together. Well, you can take arcs and add them together as well. That's the only thing they're really showing there. So I could do this. Just don't be afraid to add arcs together. You could say AB, arc AB plus what? Arc BC equals what? Arc AC. Right? Do you see that? See, there's the first one. There's the last one. They share the same thing in between. So A and C is going to be the sum of those arcs. All right? That's all that is. That's not really that tough. All right, let's continue. Let's do another thing. And this will be the last thing that we do. I'm going to make this just a little bit bigger. Now, we've talked about the arc and the being measured with an angle, but now what we're going to do is we're going to talk about the actual distance around the circle. Now, we had a lesson yesterday, and we had a homework already that we went over about the distance around a whole entire circle. What word do we use to represent the distance around a whole entire circle? Circumference, good. So, but this time, I'm not going to find the distance around a whole entire circle. I just want to find the distance of this arc, okay? This right here. Anyway, you get the idea. So, I want to find the distance from here. Let's use something else. Let's use x and y. How about that? All right, so I want to find the distance from x to y. You with me? And we'll call this circle Z. Let's say, this looks close to 90, but let's say it's like 80 degrees, just so we don't make it 90. All right, so let's say this is 80 degrees, and I want to find out how far is it from here to here. I also have to know something else. I have to know the radius. Let's just make this easy again. I'll say the radius is 5 inches. With that information, we can actually find the distance just from this part of the arc to this one, or this part of the circle to this, from x to y, walking around the circle. Not straight through it. Kind of looks like it's going through it, doesn't it? But I'm actually walking around it. Isaiah, you with me? Okay. All right, so that looks a little bit better. All right, so we want to walk around this thing. Now look, the distance around the whole entire circle would be what? It would be 2 pi r. So the circumference, or the distance, if I want to walk around the whole entire circle, what would this be? It would be 2 times 5, which is 10 pi. Let's just do that in our head. 3.14 times 10 is 31.4. But that would be around the whole entire circle. I don't want to go around the whole entire circle. I'm going to start at x and just go to y. All right? So how much of the circle did we go around? Did we go halfway around the circle? Did we go quarter of the way around the circle? No, we didn't. We definitely didn't go the whole way around the circle. What did we do? Sarah, you see it. Very good. I like the way she said that. She said 80 degrees out of 360 degrees. Okay? Because there's 360 degrees altogether. How many degrees did you go? You only went 80 out of what? A possible 360. It makes a fraction, doesn't it? All right? We're going to just plug all this into our calculator. But watch what we do. That's a fraction of the whole circumference. What's the whole circumference? 2 pi r. And I know the r in this case. Do you see that? That stuff you can just chuck in your calculator. And let's go ahead and do that. We got a couple minutes here. So let's take advantage of it and just put this in the calculator. So what I'm going to do is I'm going to hit 80 divided by 360. 80 divided by 360. All right. Times what? Times 2. Or we can just do this in our head. Times 10, couldn't we? And then times what? Times pi. And I'm going to use the pi button. Times pi equals 6.98. Let's just, let's go 6.98. It seems like they've been going 2 decimal places, so let's do that. So 6.98. That's the length of the arc. It's not the angle, right? I'm not finding the angle. I'm finding the actual length of the arc. And they call this little section right here arc length. So the length of the arc, if I know the radius and I know this angle right here, is just 80 over 360 2 pi r. Plug it all in. If this was 5 inches, then what is this? This is 6.998 inches. Okay? So we could do that. It doesn't matter how far around here. I can just put whatever angle, right, that I went through, put it over 360, and then just do the 2 pi r thing. That's all there is to it. Pretty simple? Yes. Thanks for your response to that.
Yes.
All right, thank you. Are you Simba or Mufasa? I get mixed up. All right, so here we go. This is it's section 10.2, and it's page 696,
Why are you writing it on YouTube?
697. Oh, I gotta hurry. And then it's 12 to 23. I'm breaking them up. It's 26 to 41. I'm gonna have to shut this off soon. 45 to 50. Right on time. Say bye, everybody.
Bye.